Okay, so just turning the camera on for another repair. This time we got a 820000165, which does not power up. We do have, let's see, there we go. We do have green and then orange light, but following that, no fan activity. So disconnect from power and take a look around the board, see if we can see anything. It's obviously wrong. I'll just disconnect the power board and the fan for now. And looks like we don't actually have any prior repair attempts on this board. It's reasonably clean as well. Okay, so top side looks good. And reverse side. So starting behind, just behind the CPU area. There is nothing, obviously, corroded just yet. Do have a fair amount of dust caked on the board, so definitely could use a clean, but other than that, nothing really to complain about. Oh, hello. Okay, so we have a couple of, well, one capacitor that looks like might be part of a current sensing network there on the ISL 6259. So that's one spot to look out for. And incidentally, that's probably the first thing to check, as that's generating the primary system rail. So a little bit of corrosion on this part. I don't know immediately offhand what that is. It's a Texas Instruments part though, so it might be something related to Thunderbolt, potentially. We'll have to have a look at that. And the backlight area is a little worse for wear. Trying to decide if there's a little bit of oxidation on that test point there. And decide if that little bulge in the chip is a blowout or just, okay, that was just flux. Okay. So we're okay on that front too. Just turn down the brightness a little bit there so you guys can see. Yeah, so it looks like it's just the ISL 625995, whatever that part was. SMC area looks good. Bit of dust again, should be cleaned, but nothing that's obviously corroded. So we're good around there. Oh, hello. Alright, so that's another regulator, another TPS, Texas Instruments part. My guess is this one is probably the 3v3 or the 5-volt, or possibly, if they're still doing it on these models, the combined 3v3 and 5-volt S5 S3 regulator. Okay, so yeah, likely just a power problem on this board. So we'll have a quick look at what this TI part over here is. Flick over to the board view. So it's this one. Yeah, I think that's the Thunderbolt chip, 3220. So yeah, okay. Wait, sorry. 3220. Yep, just the mux. Or is that a redriver? Yeah, it doesn't matter. So we'll probably just have a go at reflowing that, just cleaning up the joints. But first we'll get power restored to it. Yeah, it doesn't look like it's just a little bit of surface corrosion there. It doesn't look like there's anything substantially wrong with that chip. And this side too. So we'll start with our power. Power being the 6259. And yeah, so this last two pins on the chip. So if we flick back over to the board view, yeah, okay, it's the charger current sense in circuit, so 7122. And that's probably the only thing that needs to be fixed there. It looks pretty bad, but it doesn't look like there's any significant pad damage to that. So hopefully that cap has just failed short circuit, so we're not actually getting, well, we're just getting a shunt to ground. So we'll just double check that. Okay, it's not shorted, but so that was 7122. Let's see what its function is. Okay, looks like it's just serving the purpose of a filter on the output of those two 10 ohm resistors. So just a small low pass filter effect there. We'll replace that part. Looks like it's a 100 nanofarad cap, 0402 size. So I'll grab those parts and I'll be right back. Okay, and we're back. So just take the damaged part off. Ugh. Actually, that doesn't look all that damaged. So I'm still going to replace it, just as a matter of course. I think there might have just been corrosion on that, and that's it. So I don't think my iron's going to be able to manage that on its own. There's not enough room to get the whole tool in there, so I'm just going to resort to the hot air. This one. Okay, so I'm smelling something quite sugary on this at the moment, so my guess is this was coffee. Although that could be the flux as well. Oh, okay, I stand corrected. That left side did not look well soldered at all. We got black pad there, so a little bit of corrosion. That's right, we'll clean that right up. It probably wasn't affecting the function that much. Like I said, that cap was in a filter configuration, so under DC conditions, you don't expect it to really be doing anything. Of course, for AC performance, that capacitor is required, because you will get instability potentially without it, depending on what sort of circuit there is on the input of the ISL 6259, and how it's sampling that. Whether it is sampling it even, it could be an analog circuit, but still. You do want to filter out components that you don't particularly care about, frequency components that is. So it's unlikely that this is going to be contributing to it. My money's on the other TPS part that we saw up on the other end of the board. My guess is that one of the S5 rails is missing. Okay. So we'll just put down some fresh flux. These pads. And drop in our new part. $100 nanofarad 25 volt cap. This is lead-free solder, so it should have a lower melting point compared to the lead that's likely on these boards by default. Okay, so just do a quick power check again, see if there's any changes. Again, unlikely, because of the nature of how that cap is used in this circuit. It's unlikely to have made a difference to the issue that we've got at hand, or unlikely to have contributed. Okay. Bring the fan over. And yeah, somewhat unsurprisingly, there's no change, no power. So we turn our attention now to the TPS part, which here. And let's have a look at what function it serves. Again, my guess is that this is the 3D3 and the 5 volt dual converter. So U7510, sorry, 01. Yes, so we've got our 3v3 S5 rail on one end and our 5 volt S4, S3. And let's just double check what parts we need to address here. Interesting. There is corrosion there, but nothing overly catastrophic, so we'll see if we can get away with just cleaning it. So the top part, the larger capacitor is 7501, which is just a yeah, 220 nanofarad, and that's just decoupling for the VRAF2 rail there. And what else do we have? We also have the resistor next door, which is not looking too bad, but we can check him. So yeah, I think start with the capacitor as well, we'll check that last 0201 capacitor in the corner, which is C7538. And that's part of the compensation network. So I believe I've got that part on hand. This one's arguably more important than the 220 nanofarad is. This would contribute to any a lot of instability, whereas you'd be a little more forgiving with the with C7501. But let's just replace everything in that area. Doesn't matter, of course. A little curious why the damage is so localized to a few components. Very interesting failure modes, obviously, that you tend to see on boards. Some of them are just catastrophic, obviously, and people have spilled something on it, which fair enough. But tends to be these more localized failures that you generally can't piece together that well what happened. The failures tend to be more subtle as well. There's no direct outward appearance, especially on things like chips. So you rely on how the board's behaving or how the system's behaving rather than relying on any visual cues or indicators. I think this one here is going to be fine again, but just want to replace it as a precautionary measure. Sorry about that, microphone cut out for a bit. Okay, so we'll check that resistor that's sitting on its own there now, just to verify that he's okay. He looks soldered onto the board. I just want to check that that's indeed attached properly and it's the value that it should be. So R7538. So the two test points we're going to use are this one and this one, just to verify that the connection to the board is fine as well. So R7538 is again part of that compensation network, so it should be 7.5K. So we'll check. Across these two pads here. And we get 7.59K. Close enough. So that should be fine. We've got a bit of black pad on this 0201 capacitors, the one that's part of the compensation network there. So we'll just make sure that that pad's clean. It's probably good enough, but okay. I'll put down some fresh flux, and I'm just going to go and get that 0201 capacitor as well. Okay, so it looks like I don't actually have an 0201 4.7 nanofarad capacitor. Just double check that that is what it is. 7538 is, yep, 4700p. I do have an 0402 one though, so that will have to do. So we'll start by putting the 220, yes, 220 nanofarad one down. I'll come back for the 4.7. Okay. Yeah. And the 4.7, I think I'm just going to place across the to the test point. Should give us the right distance in the pads. Yeah, that'll be perfect. As close as possible. There we go. I swear that's legit. Doesn't look the part, but the electrons don't care. I'll just give the area a quick clean. Especially around the flash up here. All the flux seems to have pooled around there. Got enough. Get our fan back in. Okay. You guys can see that. And fan spin. Okay, and we have the system back together now, so we'll just connect up our power. And we have fan spin. And oh, there we go. System is running. That was it.